next week we will have a quiz about pH and buffer. Okay, so it's gonna be 4-point quiz.
Doctor, about what?
Quiz. pH and buffer.
Yes, what? Yes, okay.
Okay, and then after we have a quiz, so next week, right? Then after that week, which will be 2 weeks after, we'll have a lab again. Okay, the second lab. So those who didn't do a lab and who are not in Georgia, I talked to office if it is possible to make it up. So they said they will consider this one, discuss about that, but I cannot guarantee anything. Because as I was told, people, so as I was told, people were warned about practical work. So they're supposed to be on site when there is a practical work. So those people knew in advance that they're supposed to be on site, okay? So you guys knew about this. So then I don't know. So they will decide if you can take makeup lab or anything like this. Anyway, so next week there is a quiz. I'll send out the email. Also, I'll put some information on Moodle. And then after the 2 weeks after, we'll have a lab again.
Doctor?
Yes?
I get in the first exam you make 2 grade.
Yeah.
And the 2 exam for 4 grade. And you put for me for 4 grade.
No, I didn't understand. Can you write the email to me, please? Write your ID number, write the question you have, okay?
Doctor, I send the email for you. And
I think
can you check this review?
I think I put all grades on, for the quiz. I checked it again for everyone, and I think I put all of them in there, no?
Doctor, can check this in review in Moodle. And I send photo for this for my grade in email.
You're talking about the quiz or exam?
In quiz and my exam in the quiz.
Okay, so about the quiz, I think that I put all grades in there. So
I send my ID number. Can you check?
Okay, doctor.
Okay, so
doctor, he said
can you send it to my email, not here, but to the email? Please send it to my email. This ID number.
Doctor, I send in your email.
Okay. When did you send it to me?
In email for you.
When did you send it to me? Now or before?
Mata.
Before 1 week.
Then I checked everything, I think. I checked all scores and all grades on Moodle and quizzes. So I think I checked it, but okay, I'll check it again.
Thank you, doctor. I will send
doctor.
Yeah.
And
doctor and me, you don't put my mark in quizzes.
Okay, I really don't know why it's happening because I just checked all marks and all.
Okay, I check right now. I check my model right now. You don't put me any mark in quizzes.
Okay, so which part did you check? Like which option?
Great.
Yes, but what is the option?
Oral
say
presentation.
oral presentation.
Quiz.
No, you should check oral presentation.
Doctor, me, I
oral
check
presentation.
Oral
Yes,
presentation.
I already. Okay, doctor, in oral presentation, I already have 6 mark.
Yeah, that's it. So what else do you want?
I said about the quiz.
Which quiz? So that quiz goes to oral presentation. How many times I have to explain that? So it goes to oral
علامات
presentation.
الكويز حطهن على الأورال.
Yeah, so I explained at the very beginning that we are not doing like this kind of oral presentations. It's going to
Okay.
be quizzes, okay? I explained it at the very
Okay,
beginning.
doctor.
What else? Any other questions?
Excuse me, doctor, can I say something?
Sure.
Doctor, because I attend a little bit late and I didn't catch the whole matter that you are speaking about, the lab part, because of some problems that I sent previously an email to you, and top of
Yeah,
them it
I
is
remember that. I remember that.
visa
But
process. So I have a request. I have a request to doctor. Is it possible to replace this lab part with doing project or any additional work? Because I think until final exams, we will not be able to come to Georgia. Is it possible to you to replace this lab part with doing project or something like that?
okay, so I was told that you guys were told about that you have to be in Georgia when there is a practical work. So did you know this information? That you're supposed to be here.
Yeah, of course, but you know, doctor, it is out of our hand. You know, this is related to visa process. First of all, if it is possible to you to replace this lab part with doing project or presentation or something like that, we will so appreciate
Okay,
you.
okay, I understand. So I will consider again. So I'll consider this kind of request, and I'll see what's gonna be the option. Okay, but before that, I asked the office if there's any possibility to make up the lab. So they said we'll think about that one, but you cannot guarantee anything. Okay.
Doctor, I already sent an email to manager and Dr. Sufo, and all of them said Dr. Nichols is somebody who have to make a decision regarding this problem.
Yeah, another thing, I need to have a proof that you are not here and you didn't miss the lab for.
So which kind of document do you need?
Well, the document that you are not here, for example, you were not here for that time. I think the office should know that or not. I really don't know.
Most of us and my classmates send an email and inform all of the members that they should to inform.
Because when I asked the office, they said that they don't know exactly if you are here or not. So is that true?
What?
Okay, never mind. Okay, I'll think about that. What's gonna be the option?
If possible to replace it with other homework, I will be so thank you too.
Okay, I understand. Okay,
Thank you,
any other issues? Okay, then let's just continue with the class.
Doctor, excuse me. Can you send email for you in the chat?
It's better to send it to the email because right now I'm going to explain. I talked about the class, and then I might not have time to check it in the chat. Right now I'm checking, but you know I need to have it after the class as well. So once I finish this Zoom,
send the email again.
yeah, send it to my email. Yeah, so it will stay in my mailbox, so I'll check it later. So right now, if you send it to the chat, once we finish the Zoom, it will be gone, right?
Okay.
So send it to my email. Okay, so let's just continue with buffer in the body, which we discussed last time. We discussed about the pH and we discussed.
Excuse me, doctor. A last point: is it possible, in your own opinion, to replacing this lab part with other homework, for your own opinion, not related to exam center or other officials?
I mean, everything is possible. Everything is possible, right? If you want, everything is possible to replace with something. Of course, it's not like equivalent of the lab.
Yeah.
It's not equivalent because people came to here like they did some job and stuff like this, and those who are not here, there's a sitting in front of computer. It's not a lab, right? You cannot do the lab in front of computer. So this is not equivalent. So I need to think about what's going to be the possibility. Okay.
So if it is possible participating this lab part before just exact before final exams time.
So
it
this is
more
what
possible
I'm
to
asking, if it is possible to make it up. So because it's time, it's
we are not
addition,
sure,
it's
but we are not
additional.
sure about the process.
So I mean, it's additional 2 hours, right? You have to work in the lab. So I have to have this kind of ability to do it. So you
So-
have to come to the lab and work for 2 hours. Not only you, by the way. If there's somebody else, they also need to come. So if it is possible, that's okay. If the office will say that okay, we can do that.
You know, Doctor, we have planned to come to Georgia after our visa process, but we are not sure when will come the exact time.
Okay, so I understand your issue. So I
So
understand that.
I will be so thankful if you can help me regarding this problem, because it is completely out of our hand.
Yeah, I already hear your issue. So if office says something towards like making up the lab, that's okay. If not, then we need to think about how we can make it equivalent to the lab. Okay.
Okay, thank you.
All right. So let me just continue with the class, please. All right. So we discussed last time about pH and buffer, and let's just practice a little bit about that. So what can cause actually the change of pH and buffer in the organism? So the change of pH is related to the change of buffer because all buffers have some buffering capacity. So if this exceeds, if the change of pH exceeds the buffering capacity, then the pH will be changed. And the change of pH causes acidosis if the pH is less than 7.35, and alkalosis if a pH is 7.45. And this can be developed by different things. For example, from breathing troubles, right? Because the amount of carbon dioxide is not regulated, or some kind of drug prescription. So you take, if a person takes some more drugs, like, you know, on a daily basis, and it exceeds some kind of norm, maybe there might be some change of pH. After some exercises, the pH can be changed, and it causes some muscle cramps and nausea, and so on and so on. There are many reasons of that. So, for example, even there is a issue with collective fainting spell, which is too much breathing, let's say, like that way, when there is a lot of loss of carbon dioxide, and then it really changes the pH in the organism. So acidosis, for example, acidosis can be because of the decreasing of the pH, and so why it can happen? Because there's many reactions with the change, which changes the equilibria, right? And then pH can be changed. We discussed about this reaction last time, when there is equilibrium between carbonic acid and carbon dioxide and water. So we can have this bicarbonate ion and hydronium ion. So there is an equilibrium between all these components. And if this equilibrium is changed, then we must expect a change of pH. There is two different types of acidosis. One is respiratory acidosis. The other one is metabolic acidosis. And for example, respiratory acidosis is because of decrease of pH, which is developed because of the blocking of air passage due to inhaled food, okay, or food or removal of the blockage restores. So if the food is removed, so the blockage is restores normal breathing and return to the optimal pH. So basically, it's related to the breathing problems. The other one is well, this one can be restored more easily, but another one, which is metabolic acidosis, it's more like complicated because it results from the excess of other acids in the blood that reduce the bicarbonate concentration. Okay, and it can be consumption of high fat and low carbohydrate diet, kidney failure, dehydration, aspirin poisoning, by the way, also can cause acidosis, and so on. This is more like long-term treatment, metabolic acidosis. Yes, so usually the organism attempts to restore the equilibrium, and again, it's related in case of respiratory acidosis. It's related to the intensifying breathing. Okay, or in case of metabolic acidosis, it can be more long-term treatment. Okay, and yeah. Alkalosis, it can be caused by hyperventilation. For example, if you look at this picture, when people are exaggerated and excited, they breathe too much, and during this breathing, carbon dioxide is getting out from the organism. So too much because it's hyperventilation. So and blood pH increases because of removal of this carbon dioxide, and so. Yeah, for example, it says that in their excitement, teenagers have hyperventilated their increased breathing rate, which removes too much carbon dioxide from their blood, and they are suffering from respiratory alkalosis. Okay, so how the body responds on this is that by fainting to decrease respiration. Basically, after fainting, so people do not breathe that much, right? So then gradually this kind of hyperventilation decreases, and the carbon dioxide goes back to the normal. Yeah, so this is a response of the body of this kind of hyperventilation. Okay. All right, so in order to understand how this pH can be changed from different acids, for example, which can affect on pH, we need to consider that there might be diprotic and polyprotic acids as well, together with monoprotic acid. So monoprotic acid is which contains only one hydrogen. For example, HCl is monoprotic acid, right? So for example, I'm sorry, HCl is monoprotic acid. Okay, so but H2SO4, it's a diprotic acid. Why? Because there is two hydrogens in there. Or it might be even more. For example, H3PO4, which is 3 protons in there, so it's like polyprotic. Okay. Yeah, so diprotic and polyprotic acids can generate more than one hydrogen ion, right? And but usually the dissociation of this kind of acid, so let's just look at this case, and dissociation of this kind of acids is more intense for the generation of the first hydrogen ion. Okay, So this Ka is higher than Ka2. Okay, it's higher. And the second generation of second hydrogen is more slow and it's not that intensive, but still it can generate H plus as well. Yeah, so you can see that the conjugate base in the first, here it's conjugate base, right? This bicarbonate, but in the second part, it becomes conjugate acid because conjugate base is going to be this one over here, right? Yeah, so as I said, for the first, for the given acid, the first ionization constant is much higher than the second one. Usually it's like this. Here you can see the list of, yeah?
Doctor, just can you repeat last thing?
Yeah, so this is what I'm saying, that this constant of dissociation is much higher than the constant of dissociation for the second case. So what I'm saying that
Doctor, because the first one may be diuretic and the second one propionic acid.
so the first one is basically diprotic acid, and
Yes.
to lose this first hydrogen, it's easy. Okay, it's easy
Yes.
to lose it. So, but for the second one, once there is only one hydrogen over here, to lose this hydrogen is not that easy. It's more difficult because, yeah.
One, Doctor, one hydrogen polyprotic and more than one diuretic. Yes, Doctor.
So diprotic is when there is two hydrogens. This is diprotic, okay?
Two. Yes.
Di means two. This means two. Poly means many, okay? Poly means many, right?
Good.
But mono means just one. Mono.
Okay, thank you, Doctor.
Okay, so these are dissociation constants for different acids, and you can see that sulfuric acid has very large Ka. Okay, very large one. This is the Ka for the acid, and this is Kb for the conjugate base. Definitely, for the acid, it's very high. For conjugate base, it's very small. And so on. So oxalic acid has a little bit lower dissociation constant, and so on. Whichever has higher dissociation constant, that's the strongest, stronger acid. Okay. It says ionization constant, but it's the same thing for polyprotic acid and their conjugates. How to measure the pH? So, before we go to the measurement of pH, how to find the concentration of either one or another reagent. So we are talking about acid and base, right? So we did quite similar thing in our lab when we did titration of ferrocyanide, right, by zinc sulfate. A kind of a similar thing is here. So, but this is about neutralization reaction. If we say if we know the concentration of NaOH and we do not know concentration of HCl, we can find out what is the concentration of HCl by doing this reaction. And we can measure, for example, pH. Once the pH reaches the 7, so this is acid-base titration, this is potentiometric titration. So once we see the pH meters, this one reaches 7, so then we can stop the titration and find out how much sodium hydroxide was consumed to titrate HCl. And then we can find out what is concentration of HCl if we know the concentration of NaOH. This is the titration curve and the profile of change of pH during the titration. As you can see on the axis, on the x-axis, so this is x-axis, right? We have milliliters of NaOH. Okay, so then we know the concentration. That's the concentration over here, right? So we know the concentration, and so and then after titration, you can see on the curve that at the very beginning, so we have pH over here and we have volume, right? So at the very beginning, when when the amount of added NaOH, so we are adding this one to HCl, for example. Okay, so this is the HCl. We don't know how much we have, and we are titrating HCl. So again, we have HCl in our flask. Say this is HCl, and we are adding NaOH. Okay, so this is what we are doing, and this is a burette, let's say. So we know the concentration of NaOH, and at the very beginning the pH is 0, right? So why it's 0 at the very beginning? Do you have an idea?
Because we add strong base to strong acid.
Yes, but why the pH is 0 at the very beginning? So what do we have at the very beginning when the volume of NaOH is 0? So we are at this point, so you can look at this one, that volume of NaOH is 0, right? It's over here. It's 0. So, and the pH is also 0. I'm sorry, pH is a little bit more than 0. Maybe it's 1. Why it's so low?
Because it is a so strong acidic substance that we have.
Yeah, so this is only acid we have in there. So we do not have anything else. This is only acid in there. This is why it's very low. And then we continue adding this NaOH, and gradually, the point goes to, so it increases and at some point it goes to the so-called equivalence point. And here we have pH 7. So right here at this point, it means that we neutralized completely HCl with NaOH. Okay, we completely consumed HCl, which was in the flask. Okay, and then once we continue adding NaOH, then pH goes very high, right? Because right now we have only NaOH in the mixture. Okay, so this is why pH is high. Basically, there is no HCl left in the mixture, and now opposite. So we have excess of NaOH. Okay, is it clear?
Yes, doctor.
Okay. All right. Say it again. All right, so this is just a change of the concentrations of, again, it's titration against acetic acid, or opposite, maybe acetate ion. This is the same thing, so I'll skip this one. All right, so now let's just discuss about how to find the pH of particular solution. So it says over here that the concentration of H+, if you start from here, ions in a bottle of table wine was 4.1 10 to minus 4 moles per liter. Okay, and then the bottle was open and left and used a little bit and then left on the bench for a long time, and then the pH was checked. I'm sorry, so then concentration was checked, and it was 2.3 10 to minus 3 moles per liter, right? So it says calculate the pH of the wine on these two occasions. So we know the concentration of H plus, right? So how to define the pH? What do we need to do? Do you guys remember for the last time? So, okay, so there was some interruption of internet I had. So, do you guys hear me now?
Yes, doctor.
All right, so let's just continue with the, yeah, so this is where we stopped. And yeah, so the strategy is that we need to find the negative logarithm of concentration of H plus, right? And that's the solution. You remember this equation over here, right? So when we know the pH of, I'm sorry, concentration of wine, so that's the concentration of wine, we just plug in this one here instead of H, so that's the over here, and we will get 3.39, okay? The same thing about the concentration, yeah.
You will pass the logarithm of 4.1.
Yeah, so for this one, you need to have some special calculator which can calculate this kind of number, but
Okay.
but on in the quiz, for example, I'll give you like 4.0, and then I'm sorry, not 4.0, but say 10 to minus 3, 10 to minus, I don't know, 10 in power 1, 10 in power minus 4, stuff like this. I'll not give you like number like this one, okay? So you don't need to use calculator at all. So if you have, say, 10 to minus 3 moles per liter, then you can calculate the pH without the calculator. But
Okay.
but if you have, yes, if you have number like this one, 4 or 2.3, then you need to have a special calculator for that. And now this is just an example, just giving you to it. All right. Now let's just look at the pH of rainwater. How much time I have? Okay. So rainwater, the pH of rainwater, well, it says in the United States or something, it doesn't matter. So it says that it was measured as 5.23. So now we know pH. Internet goes bad, so for some reason.
Yes, doctor, we cannot hear you on the share stop.
Now can you hear me?
Yes.
Okay. All right. So to continue about to find the concentration. So here we are given pH. So we know the pH is this one over here, and we need to find concentration. For that, we need to do anti-log. Okay. So we can solve the concentration of H plus by taking the anti-log of pH. That is, which is in general, the equation is like this one. So then it's very straightforward. So the pH, we know that this is the pH what we have, right? So we know that log of H plus is going to be minus 5.23. So to calculate concentration of hydrogen ions, we need to take the anti-log of this one, okay? So that's the whole story. So that's the concentration of hydrogen ions if we know that the pH is 5.23. Then it just calculated in more exactly, more precisely, not living like this way. So it's 5.9 times 10 to minus 6 moles per liter. Okay, So basically, there are two cases. One, you know the concentration, you need to find the pH. For that one, you take negative log of concentration. And another case is that when you know the pH, and you need to calculate the concentration. Okay. Because so the pH is between 5 and 6, we can expect that concentration of H plus to be between 10 to minus 5 and 10 to minus 6. So the answer is reasonable, definitely, right? Okay, do you guys have questions here?
Doctor,
Yeah,
Doctor,
yeah.
when we have concentration of hydroxyl, that's equal the strong concentration of strong acid.
Okay, so all right, so
Doctor.
yeah, can you hear me?
Hello.
Hello, can you hear me?